This is Module 1, the Pythagorean Theorem. This is a standard that has actually been talked about in middle school mathematics, but we're going to take it to a little bit of a higher level in this. But just to recap and kind of go through what the Pythagorean Theorem is, in a right triangle, the square of the lengths of the hypotenuse is equal to the sum of the squares of the lengths of the legs. If A and B are the lengths of the legs and C is the length of the hypotenuse, then we have the A squared plus B squared equals C squared theorem. So this is the main thing that you have to know. A squared plus B squared equaling C squared. So if I have a triangle here, the thing we have to remember what a leg part of the triangle is, another leg part, and the side that is opposite the right angle. The way I always remember it is I draw an arrow in my mind, or you can physically draw it. That is always going to be your hypotenuse. And since we're dealing with a theorem, we have to remember that a theorem is a statement that can be proven. So, all right, we have this figure here. So we have one of the reasons why we have an A squared plus a B squared equals a C squared is that if I take the A, which in this case is going to be 6, and I square it. So basically I'm creating a square on top of, or to the side of the rectangle, or the triangle. And then I'm going to do the exact same thing with the 8. So this is going to be the B. So we have the B is going to be here. So that's B. And I take the square. If I took these two areas, it would equal the area of the C, or the yellow. So that's what the Pythagorean theorem is basically stating. So the green, red, and yellow are all going to be squares. The blue is the right triangle. So that's the triangle that you're usually going to be given. So you take the area of the green square, which we find out is 36 units, the area of the red square, which is 64 units, and if you add those together, you should get the yellow square's 100 units, and you do in this case. So that's Pythagorean theorem, a little bit more in depth with it. So, finding the length of the hypotenuse. So in example 1, we're trying to find the length of the hypotenuse, so you have to first establish what your A is, what your B is, and what your C is. Now, to be honest with you, your A and your B, it really doesn't matter which one's your A and your B. The thing that really matters is the one that's C. And the C always, again, has to be the one that is opposite the right angle. So this one's going to be your C. So once we establish it's a right triangle, we're trying to find the hypotenuse. So all we do is plug it into the formula. So we know that Pythagorean theorem is the hypotenuse squared, which equals the leg squared plus the leg squared. When you add those together, we just plug in the actual numerical values, just kind of like a proof, like in semester 1 geometry. So my x squared, that's my hypotenuse squared. One of my legs squared is 6 squared, and then 8 squared. And when we multiply those together and then add them, we get 100. And the thing when you actually solve to find out the opposite of squared, you have to take the square root. So, and it always, this is kind of key, positive square root, because you can never have a negative dimension, a negative length. So we always take the positive. But don't forget that when you actually take the square root of both sides, you do get a plus or minus. That's something you can't forget, because in later level math classes that will be important. Okay, so here's another example. It says identify the unknown side of it as a leg or a hypotenuse. Then find the unknown side length of the right triangle. Write your answer in simplest radical form. This is kind of key. So if we did this, the hypotenuse, that's your x value. So that's your hypotenuse, or that's your C. So we can set up x squared, in this case, is equal to the 6 squared plus the 4 squared. And if we did this, we get 36 plus 16. Add those two together, you get 52. Okay. So, again, we have to solve. So we take the square root of both sides, square root of both sides. That goes away completely with the squared, so that cancels those out. And it says in simplest radical form. So we have 2 root 13. Well, how did I get 2 root 13? Well, 52 breaks down into two numbers. It breaks down into 4 times 13. Now, this is something in Algebra 2, but remember, if you have a pair underneath a square root, a pair of numbers, so if you want to break this down even further, you can go 2 times 2 times 13. Well, my pair of numbers, you can circle those, and one of them will come out of the radical. So 2 root 13 is going to be your final answer because a 2 comes out. One of the pairs comes out. Okay, so we have example 3. How high up on the wall will a 20-foot ladder touch if the foot of the ladder is placed 5 feet from the wall? So I have a diagram here. It represents the wall and the ladder that's placed. It's a 20-foot ladder, so we know it's a 20-foot ladder. We also know it's 5 feet from the wall, so we mark our lengths that we know. We do not know this guy, so we can call him either A or B. It really doesn't matter. Or X. Just as long as you know that a squared plus b squared equals c squared. And the important one, again, is your opposite of your right angle. That's your c squared, or your c. So I plug in what I know. So I have my a squared, my b squared. And in this case, actually, I said that a is equal to 5. That means this we're going to call b. So that's my first mistake. So there's b. So we're trying to solve for b. Square the lengths of the legs and the lengths of the hypotenuse, and then I'm going to have to subtract, and then I take the square root of both sides. So we have, in this case, we don't do simplest radical form. We say about 19.36 feet up the wall. But again, using Pythagorean theorem. Okay, so we have find the area of the rectangular rug if the width is 12 feet and the diagonal measures 20 feet. So, again, we're trying to find the area, which is length times width, if you remember from middle school or from semester 1. So, draw this. A diagonal, that's an important thing to know. It's from the upper left-hand corner to the lower right-hand corner, or from the upper right-hand corner to the lower left-hand corner. But they give us the length of the diagonal, which is 20 feet, so I label it. They also give us the width, which is 12 feet, so I label that. And in order to find the area, we need to find out what this length here is. So we have to actually figure that out. So again, we use a squared plus b squared equals c squared. So in this case, we don't know what the b is, so we call it b. We know what a is, we call it 12. We know what c is, we call it 20, because that's the one that is opposite the right angle. Square them, and then subtract, and then you get 256 equals b squared. Take the square root of both sides, and we get b is equal to 16 feet. So now we know that b is equal to 16 feet. Again, we're trying to find the area, so don't forget what the question is asking. That's a majority of the problems. People are not reading what the question is asking. They find the right part, but then they have to use this actual part to find the next part of the answer. So area is base times height, or length times width. Base times height will become a little more evident when it comes to later modules in this semester. So we do 12 times 16, and that's 192 feet squared. And the feet squared, that's important because of units. You always want to make sure that you have the proper units. Okay, last but certainly not least for this part, we have find the area of an isosceles triangle. Again, kind of like the previous one, make sure you have the area. You're trying to find out what the height is. Remember this part here, this is from, again, semester 1. This is called an altitude. An altitude is also the height of the triangle. So it says find the area of the isosceles triangle with side lengths of 10, 13, and 13. So if we dropped an altitude, that means we can use Pythagorean theorem to find out what h is. So again, I use 13 squared equals 5 squared plus my h squared, or b squared, or a squared, it does not matter. So we got 169 equals 25 plus h squared. Subtract both sides, we got 144 equals h squared. Take the square root of both sides, and we get the height is equal to 12. Remember, plus or minus, but again, we're dealing with lengths, so we have 12 meters. What we're asked to find is we're asked to find the area of the isosceles triangle. So area is the second part of it. Area equals 1/2 your base. In this case, my base is going to be 10 because it's the entire length here. My height is going to be 12. I can plug this straight into a calculator, or I can use the cancel method here, and I get area is equal to 60. And again, since it's area, you have to make sure you have the proper units. So 60 meters squared. Okay. All right. So the converse of the Pythagorean theorem, if the lengths of 3 sides of a triangle satisfy the Pythagorean equation, then the triangle is a right triangle. So some things you're going to be asked is determine whether each is a triangle. Each triangle is a right triangle. So I give you that the lengths. Now the main problem here is, how do you know what a squared and b squared and c squared is? Well, this is c. Why is it c? Because it's the largest side. This one here is c, and it's the largest side as well. So again, plug it into the Pythagorean theorem, solve, and we show that we have a true statement. 289 is equal to 289, so this is a right triangle. Okay, what about b? Again, plug it into the Pythagorean theorem, evaluate. We come up with 2 different ones, so we can put a little slash through it saying that they are not equal. So this is not a right triangle. Okay, so this actually leads into the last point of this part of the module, is the 2 theorems. So theorem 7.3 says that if the square of the length of the longest side of a triangle is less than the sum of the square of the lengths of the other 2 sides, then the triangle is acute. So that's key. So this would be an acute triangle. And if we had the inequality the reverse way, that would create an obtuse triangle. And the thing that I tell people with this, a lot of people have trouble remembering this and then remembering this, all the diagrams and all that stuff. So the thing that I tell them is remember the saying. And the saying that I came up with is G-A-L-O. So we have G-A-L-O, I pronounce it gallo, and what that means, you have greater than, acute, less than, obtuse. So we have greater than, the a squared and the b squared added together is greater than, that means it's acute. A squared plus b squared, if that's less than, that means it's obtuse. So this is your mnemonic device right here. See if we can apply it. So classify the triangle with the following leg lengths as acute, obtuse, or right. So determine the hypotenuse first. That is the main thing, because a lot of people, they just kind of go on automatic pilot and don't really actually figure out which one is the hypotenuse. So in this, what I see, if I plug this into a calculator, just for reference sake, this is about 2.8. So the largest one would be C. C is the greater one. So what I have here, I'm going to put a box. That means 6 is going to be my C. And my other numbers, A and B, are going to be 4 and square root of 8. The thing you don't want to do is when you plug it into the formula to figure out whether it's obtuse, acute, or right, you don't want to put the decimal form of a radical in for the formula. Because what happens is you round it, and then if you round it, you actually end up getting an incorrect answer. So you want to make sure that you put the radical one in the actual formula. The reason is, you'll see why in a second, we have 4 squared, gives us 16. We have the square root of 8, gives us 8 because we square it, you get the exact same thing. Then we have our box that determines the inequality or equal sign. So once we do this, we get 24, and then we got 36, and I determine we have less than. So remember our gallo statement, we have G-A-L-O, greater than acute, less than obtuse. Well, I have a less than. So that means less than is obtuse. That means this is going to be an obtuse triangle. So stick with the gallo and you should be okay. Okay, what about the next one? I'm going to set it up for you, and then you can do it on your own and see what you think. So we have 20 squared plus 21 squared. You have your inequality symbol or equal sign that will be here, and then we get 28 squared. And if you do everything correctly, you should get a cube. And that's it.